Now we're going to do another chain rule problem, but this time I copied over the second form of the chain rule. We're going to use this form of the chain rule. So this says that if y can be written as a function of u, this notation doesn't mean y times u, it means y is a function of u. And u is a function of x. U is a function of x. So dy dx is equal to dy du, that's the derivative of this, times du dx times the derivative of this piece. All right, so let's apply that directly right over here. Okay, so we want to find dy dx, so we'll write dy dx is equal to, so first we're going to do dy du. Well, here's y as a function of u, so just take the derivative right here. Take the derivative of the square root of u, and remember that square root is the same as an exponent 1/2. So you bring down the 1/2, and we have u to the 1/2 minus 1 to the minus 1/2. So that's this piece. That's that's dy du. And now we're going to multiply by du dx. So here's u as a function of x. Okay, so du dx is, just do the power rule here, 3 times 4, so we have 12x, subtract 1 from the exponent, 12x squared. All right, so that's dy dx, and I'd like it written in terms of x. That's the variable that we want. All right, so let's just do that. So we can just, we know that we have that u is equal to 4x cubed plus 7, so we're just going to put that right here. Right here we're going to, instead of writing u to the minus 1/2, we're going to write 4x cubed plus 7 to the minus 1/2. Okay, so let's do that. So just to finish this off, we write 1/2. U is 4x cubed plus 7. That's u to the minus 1/2 times 12x squared. So that's our derivative. All right, and now you're ready to do problem 5. So let me show you that. Problem 5 is right here. Okay, so pause the video, copy problem 5. You can do that now. Okay, now we're going to talk about implicit differentiation. So first let's see what we mean by an explicit function and an implicit function. Well, an explicit function is simply a function that's solved for y. It's written as y equal some function in terms of its variable, in this case x. Here the very same function is written implicitly. Just do minus y, subtract y from both sides, and this function is no longer solved for y, so this is considered implicit. Now here we have another function that's also implicit. It's not solved for y, and this function can't be easily solved for y because, you know, we have y squared plus y plus x equal to 2. We can't easily solve this for y. So let's start by differentiating. Let's start with this example, y equal x squared plus 5, and we're going to differentiate this in the usual way. Let me just make this a little bigger. Okay. In the usual way, we have dy dx is equal to 2x. And now our very same function written implicitly, let's differentiate it while it's written like this. So we'll take the derivative of 0 is 0. The derivative of x squared is 2x. And here we write minus dy dx. And the derivative of 5 is 0. So basically we get the same thing. If we add dy dx to both sides, we have dy dx is equal to 2x. So we just did implicit differentiation. But what about if we have something like this? All right, how are we going to differentiate y? Well, that'll just be dy dx. The derivative of x will be 1. But how are we going to differentiate y squared? All right, so let's see. Let me just scroll this up a little bit. So let's see how we would differentiate that. Let's look at an example. Let's look at that example. All right, so we had, let me just look at this again. We had y squared plus y plus x equal to 2. And keep in mind that we are thinking of y as a function of x. So we'll write y is a function of x. So just to emphasize that, instead of writing y, I'm going to write here y of x. Y is a function of x. So this is, instead of y squared, I'm writing y of x squared. And instead of y, I'm writing y of x. All right, again, just emphasizing the fact that y is a function of x. Y depends on x. Now let's differentiate this. Okay, so this is going to be differentiated the same using the chain rule. We're going to bring 2 down. That'll be the derivative of the outer, and multiply by the derivative of the inner. All right, here we're just going to multiply. Here we're just going to take the derivative. So here we have y prime of x. The derivative of x is 1, and the derivative of 2 is 0. Okay, so that's it. We differentiated implicitly. Now let's go back to our shorthand notation. Instead of writing y of x, we'll just keep in mind that y is a function of x, not write it out not write it out like this, not emphasize it. We'll just go back to y. So I'm going to write 2y. Instead of y prime of x, I'm going back to y prime. Plus, instead of y prime of x, I'm going back to y prime. So that's it. We just differentiated implicitly. Okay, let's look at another example. Here we have x squared plus y cubed is equal to 100. And what we want to do is we want to find dy dx. And this time we're going to, in the end, we're going to solve for dy dx. So what we want to do here is find dy dx. If you want, you can use the notation y prime, same thing. All right, so this time I'll use dy dx. All right, so let's take the derivative of the first term. That'll be 2x. And remember, when we take the derivative of y, we're keeping in mind that y is a function of x. And we're taking the derivative with respect to x. So here, this is y cubed is like the outer function, and y is the inner function. So first, the derivative of the outer, that's 3y squared, times the derivative of the inner, times the derivative of y, that's y prime, or dy dx, is equal to 0. And now let's just solve for dy dx. I'll subtract 2x from both sides. And then divide both sides by 3y squared. So we have dy dx is equal to minus 2x divided by 3y squared. So typically when we differentiate implicitly, very often, usually in fact, the derivative is written in terms of x and y. All right, here again we want to find dy dx of this function, which is written implicitly, but we want to do a little bit more. We wanted to find dy dx when x is equal to 5. So we're going to be finding a particular value of dy dx. All right, so let's first differentiate implicitly. Okay, so here we have, let me just copy this over, x squared plus y squared is equal to 169. Derivative of x squared, that's 2x, plus derivative of y squared. Now keep in mind y is a function of x. So we have an outer, that's 2y, times the derivative of y, that's like our inner function. Okay, that's our chain rule there. Equal the derivative of 169 is 0. And now I want to solve for dy dx. So I'm going to subtract 2x from both sides. And now divide both sides by 2y. So we have minus 2x over 2y. Okay, just simplify that. That's minus x over y. Okay, so that's dy dx. So here's dy dx. And now we want to find dy dx when x is equal to 5. All right, so what we're going to do is we're going to substitute, we're going to put x equal 5. But the question is, what's y equal to? Well, we have to go back to the original equation and say when substitute in x equal 5 to figure out what y is equal to. All right, so let's do that over here, and we have when x is equal to 5, we have 5 squared plus y squared is equal to 169. 25 plus y squared is equal to 169. Subtract 25 from both sides, and we have y squared is equal to 144, and y is equal to 12 and minus 12. We take the plus minus square root of both sides. So we have y is equal to 12 and y is equal to minus 12. That is when x is equal to 5. So when x is equal to 5, we have y is equal to 12 and y is equal to minus 12. So dy dx when x is equal to 5. Okay, so let's do that. When x is equal to 5, we have dy dx is equal to, subbing in right here, minus 5 over 12, or dy dx is equal to minus 5 over minus 12, which is 5 over 12. Okay. So we have two values. Now that's not surprising because this equation, x squared plus y squared is equal to 169. 169 is 13 squared. This is a circle with radius 13. 13 squared is 169. So let's just look at the picture that we have here. Okay, we have let's just draw a circle. Radius 13, and let's say this is x equal 5 right here, and here we have our two y values. This is 5, 12, and this is 5 minus 12, the two y values that we found. And here we found that the slope of this tangent line, or that's y prime, the slope of this tangent line, okay, that's when x is equal to 12, is minus 5 over 12. And that looks like a negative slope, right? And this one down here looks like a positive slope. And we found that this one is minus 5 over minus 12. Oops, let me just get that back. That one's minus 5 over minus 12, or slope 5 over 12. And that does look like a positive slope. It's going up from left to right. Okay, so now you could do problem 7. So let me show you problem 7. Sorry, not problem 7. I meant problem 6. So you can do that right now. So there you have problem 6. Copy it down, and you can do problem 6 now. Here we have another function defined implicitly, and we want to simply find dy dx. All right, so let's do that. So notice this first term over here is a product of x squared times y, and in order to differentiate this term, we're going to have to use the product rule. All right, so that's the first time we're doing that when differentiating implicitly. We have to use the product rule right here. So let's do that. So we have the product of x squared times y. So we're going to do, following the product rule, we have the first times the derivative of the second. So here's the first. The derivative of the second, well, that's dy dx. Okay, continuing on with the product rule, plus the derivative of the first, that would be 2x, times the second, that's times y. So all of this is the derivative of this first term, all this. So now we move on to the second term, plus 3 times the derivative of y, that's dy dx, is equal to the derivative of the constant 4, which is 0. All right, so that's it. That's differentiating implicitly. We had to use the product rule here. Now, let's solve for dy dx. Sometimes we do that. So the way we solve for dy dx is first keep dy dx on one side of the equation and subtract off any term that doesn't contain dy dx. So we'll subtract 2xy, put it on the other side. So we have x squared dy dx plus 3 dy dx is equal to minus 2xy. Okay, remember we're solving for dy dx. Here we have two terms containing dy dx. We want a single term with dy dx. So what we're going to do is factor out dy dx from those two terms. And we factor it out, we get x squared plus 3 in parentheses. Okay, and then just to get dy dx by itself, divide by x squared plus 3. Okay, so this is it. This is dy dx. I'll just write it over. Dy dx is equal to minus 2xy divided by x squared plus 3. And notice once again that dy dx is expressed in terms of x and y here on the right-hand side. And that's usually what occurs when we differentiate implicitly. Okay, so now you can do the next problem. That's problem 7. Okay, so let me show you that one now. Okay, here's problem number 7. So just copy that down and you can do that problem now.